Let's look at another example for hypothesis testing for the mean. This time, as you can see here, our test is left tail because we are looking if the Oklahoma City has less than the national average. So we are testing the Oklahoma City population average is less than the national average, less than 45,000. So once we decide on the hypothesis, then we can figure out like which formula we're going to use. So we're going to use the left tail because our hypothesis is left tail. So let's enter our data. $45,000 for the population mean. Level of significance is 5%. 5% right here, 5%. Population standard deviation is 5,500. Sample size is 60 and sample mean is $39,000. So the next step in the hypothesis testing is to find out the critical values. Let me copy and paste the graphic here so we can see how we can decide the critical values. So as you see here, the critical value is minus 1.645. Now how we find this is using this Excel function norm.s.inv-b5. So here you can notice that we are not using 1 minus b5 because we are looking to the left side already, so we can simply enter b5. If this was right tail, then we needed to put here 1 minus b5 as we did in the previous video. So the lower critical value now is minus 1.645. Then next step is to find out the z test value. Remember, for all the hypothesis testing, we are comparing the critical value, the critical z value with the test value. In order to find the test value, we need to use this formula. Mu x bar minus mu divided by standard deviation divided by square root of sample size. Now here on B10 you can see this formula. B8, which is x bar, minus B4, which is mu, divided by B6, which is standard deviation, divided by SQRT B7, which is sample size. So once I plug in these numbers into this formula, then z statistics is found to be minus 8.45. So where is minus 8.45 on this graphic? It will be beyond this critical value. So the decision is H1 accept, H0 reject, which means with 95% confidence we can say Oklahoma City instructor salary average is less than the national average. I can tell this with 95% confidence.